Get this? Imagine Mars giving our oceans a gravitational nudge, creating epic tides here on Earth. Sounds far out, but it's actually happening with exoplanets around a cool distant star called TRAPPIST-1. Discovered in 2016 by a powerful telescope, this system of 7 Earth-like planets is making astrobiologists go wild. With names like TRAPPIST-1b to H, these mysterious worlds are raising the question, could life exist beyond our solar system? But here's the twist. The star they orbit isn't a scorching ball of fire, it's an ultra-cool dwarf that's way chill. Let's dive into TRAPPIST-1's icy grip. Literally. This cool dwarf star's temperature, a chill 511 degrees Kelvin compared to our sun's sizzling 778 degrees. But here's a mind-blowing fact: TRAPPIST-1 is older than the sun, with an estimated age of around 8 billion years versus our sun's 4.5 billion. It's no wonder this star runs cold. The real kicker: its 7 Earth-like planets are packed tighter than sardines in a can. In one planet, a neighboring world could appear as a moon in the sky, and due to this cosmic congestion, each world causes gravitational tides that tug on its neighbors. But that's not all. These planets' orbits are doing something truly bizarre: they're sinking. The celestial dance at TRAPPIST-1, what a show. As we explore this unique system, a special connection emerges between its 7 planets. They're in resonance, moving harmoniously like a perfectly tuned orchestra. But don't let their close proximity fool you. These planets are packed tighter than the streets of Tokyo during rush hour. And if that's not enough, they've got an oceanic twist. Water makes up around 5% of some world's mass, compared to Earth's measly 0.02%. With rocky cores like TRAPPIST-1b and C, these planets might have thicker atmospheres too, a far cry from our thin veil on Earth. Let's dive deeper into TRAPPIST-1d and its mysterious mass mystery. At a mere 30% of Earth's weight, this enigmatic world is puzzling astronomers. Now, imagine an atmosphere that's either an epic ocean or a gigantic, icy lake covering the entire planet. It's a cosmic sight. This atmospheric marvel eliminates TRAPPIST-1d from our habitable planets list. But what about the other 3 worlds? E, F, G, and H are safely located at a distance where any water they hold is frozen solid. These icy giants join the not-so-habitable club, leaving only one planet standing in the search for life beyond Earth. Now we're getting down to Earth, or should I say TRAPPIST-1e. This particular gem has an intriguing mix of similarities and differences that make it a hot topic in astrobiology. It shares many characteristics with our home planet, but there's more to the story than meets the eye. TRAPPIST-1e orbits in the sweet spot where heat from its dwarf star isn't overwhelming, yet enough to prevent freezing like its icy siblings. What sets it apart is its dense core, potentially made of iron-rich material, a stark contrast to the other planets in the system. In 2018, scientists discovered that TRAPPIST-1e is less likely to have an atmosphere dominated by hydrogen, but this discovery raises more questions than answers. While conditions seem perfect for life to thrive, there are also factors at play that could make it difficult or impossible for life as we know it to exist on this fascinating exoplanet. Let's take a closer look at TRAPPIST-1e. Despite being an exoplanet that seems less likely to harbor life due to some pretty tough conditions. First off, its close proximity to the star puts the atmospheres of all planets in the system at risk. Imagine them being stripped away like leaves from their branches under intense solar winds and radiation. While some outer planets have managed to hold onto theirs, it's a different story for TRAPPIST-1e. It doesn't quite make the safe zone cut. Another challenge facing potential life on TRAPPIST-1e is its extreme weather patterns. Picture wild temperature swings, maybe even violent winds, due to the system's tidally locked nature. Daylight and darkness are starkly divided across each planet, leading to unpredictable temperature fluctuations without any regulation in sight. It might sound like all hope for life is lost on TRAPPIST-1e, but we still need to consider one crucial factor that could turn everything around. Imagine we're exploring distant worlds like TRAPPIST-1e, using our current understanding of what makes a place habitable. But here's the exciting part: those parameters might be entirely tailored to us humans. It's possible that other forms of life could thrive in environments that would be hostile or even deadly for us. They may not need water at all, or they could adapt to extreme temperature fluctuations with ease. We're so accustomed to looking for a world similar to our own in the vast universe, but what if we're limiting ourselves by assuming every form of life operates just like ours? Until we set foot on TRAPPIST-1e, or send a probe that can tell us for sure, there's always the possibility that it could be teeming with life forms that are completely alien to our understanding. Maybe today you discovered something new, and maybe tomorrow will bring even more surprising revelations as we continue to explore the mysteries of space. Before we wrap up today's mind-blowing journey through space and habitable planets, we've got a quick ask for you. Do you have any unanswered questions about life beyond Earth or TRAPPIST-1e that you'd love to get answered? Share them with us in the comments below. If you're as fascinated by magic tricks as you are by intergalactic explorations, be sure to check out our top 10 list when you click on the video link provided. Don't forget to hit that subscribe button and join our cosmic community. We can't wait to dive into more incredible topics with you in the next video.